So welcome to TruTech Training. My name's Bill Spohn. We're going to be covering the Testo 327 Combustion Analyzer and going through a boot camp of teaching you how to use the features of it. If you have a question, please ask it in the question or the chat box window, and I'll try to get to that question as soon as possible. Who's TruTech Tools? If you're not familiar with us, Jim Berg and myself are the two principals here. We have over 45 years combined experience. Jim's an HVAC instructor, works on a lot of HVAC committees, been my business partner for the last 3 years. And I have a track record of working with Walkaround and Testo in product development and product marketing, and now with TruTech Tools. We do offer Learn While You Earn, BPI CEUs, not on this specific class, but we have it on classes like the class tomorrow on the Combustion Analyzer, Combustion 101. Here are the things we'll be covering today. Trying to really crack open the 327, help you understand it, how to use it, how to take care of it, how to get the most out of it. We feel it's really important when anyone makes a purchase from us is that they really get the most out of it. First, they understand what they're getting into, and second, they get the most out of it. So just to start off with, we want to understand why are we even using a combustion analyzer? Why is combustion analysis important? We use it for the verification of safety of the appliance, especially before or after service and or weatherization, any kind of air tightening work. If you take the combustion analysis class, you find out how important the presence of the correct amount of air is in terms of combustion air, dilution air, ventilation air, leakage air. All these things affect the envelope of the house and the way the combustion appliance is run. So when you change or alter the air that's available through weatherization, then you could change or alter the combustion process and cause a safety issue. The analyzers also calculate combustion efficiency in order to determine how efficiently the appliance is operating. And again, in the seminar tomorrow, we get into more about how the combustion efficiency is calculated and what the significance is. It's not AFUE, it's not thermal efficiency, it's a hybrid value. It points in the same direction as AFUE. Increasing AFUE equipment has higher combustion efficiency, but it's kind of a hybrid parameter. And if the seminar tomorrow I keep mentioning is also free of charge, it's available, it starts at 5 p.m. Eastern Time. We have it scheduled all the way through March through various dates in the upcoming 6 months, so you're free to take a look at it, not necessarily tomorrow, but any time after that. We can also monitor the output with a combustion analyzer, the output of pollution or toxic gases. And we want to verify the conformance with the way the manufacturer recommends the product be set up and operated. Taking a look at the temperature output of the flue gas, taking a look at the pressures of the fuel coming in. We also want to, in providing all these kinds of checks on the equipment, we can help minimize warranty issues if you're a service technician, and you can also assure the equipment's operating safely and with the longest service life possible. Here's a quick overview of what combustion is, and let's see. I've got my little spotlight, my laser going here. You have 3 things necessary. You have oxygen, fuel, and a source of ignition or heat to create the combustion process. If you have oxygen, fuel, and heat in the proper proportions, you'll get complete combustion, and you'll result in more heat output, carbon dioxide, not carbon monoxide, but carbon dioxide being produced, and water vapor. And this is if everything was in a perfect world and everything ran perfectly correctly in every part of the combustion system, and there were no changes in available air, fuel, or any types of blockages or problems with the equipment. In most cases, the real world, you have at least some incomplete combustion going on. And when you have incomplete combustion, you have products that weren't in the last slide that are produced. Those products are things like soot, would be mainly visible in an oil burner system, oil heating, but it's even visible to some degree. If with a very fine microscope you could see it in a natural gas system. You have carbon monoxide. This gray box here, gray balloon, that's the toxic, the ultra-toxic gas that's produced if you have incomplete combustion. You also have toxins that come through that are entrained in the air that are coming in the system that can also be produced by the combustion process, like nitric oxide or sulfur dioxide. And these can produce, with the combination of water vapor, when they condense, produce acids. That's why you sometimes see rusting or staining on combustion appliances, because you have the mixture between these toxic acid gases and water vapor creating literally liquid acids. You also have air coming into the system, excess air that actually moves out through the combustion system. So this is more the real world. It's a little bit more complex than the perfect world, of course, and we'll show you how the combustion analyzer addresses every one of these parameters. Because you can't really conveniently measure air, fuel, and heat. You can measure heat, but not the heat flow. The combustion analyzer looks at what happens on the other side of combustion. It reads how much heat, the temperature in the flue gas. It can read the oxygen that's left over, and from that infer how much carbon dioxide is in the flue gas. It can actually directly read carbon monoxide. And some advanced analyzers can read nitric oxide and sulfur dioxide. So the combustion analyzer works on this side in order to tell you what's happening in the combustion process back here. It's kind of like an X-ray. It allows you to see indirectly what's going on the inside of the process. So this basically covers what I just said there. And this is being recorded, so you can get a copy of the recording, or if you'd like a copy of the slides. We're going to go ahead and mail the slides out. I'll just make note here. We'll mail the slides out to all attendees. It's just a matter of practice with all of our webinars. The combustion efficiency that's calculated by the analyzer is a modified equation that considers part combustion efficiency and part stack losses. And from the stack loss standpoint, that's how effective your heat exchanger is and how much excess air you have moving. It's a little complex, but basically it's part thermal, part combustion efficiency, and it tells you, and all the major manufacturers run their combustion equations about the same way. So when you look at one to the other, they may be off by a couple points, but they're all in the same ballpark in terms of indicating combustion efficiency. A complete combustion analysis involves testing all the appliances, all the fuel-burning appliances that are within a space or an envelope. It also involves testing the venting system, because the air is so important to combustion, how much oxygen you get in the air that gets through to the combustion system. If the venting is affected, it could affect how much air is pulled through. The combustion air zone, to check if that has any spillage or if there's any depressurization in the air zone. The building envelope, and worst case draft testing. So all these combine together to a really complete combustion analysis. And if you're familiar with building performance testing, I think just looking down the names of people I recognize here, many of you likely are, you're familiar with some of these things are mentioned in the BPI test protocols. But the bottom line is you can't just push the probe in the stack, push the buttons, and expect to get an answer without knowing what you're trying to measure, where you're measuring, and when you are. And our TruTech training and the combustion analysis get you a little bit deeper into this. Again, that's the thing that's happening tomorrow afternoon. Any questions at this point? I'm not seeing any in the chat window at all. Okay, I'm going to keep moving along here. So at a glance, what is a 327 made of? It's a combustion analyzer. It does have English menus, even though it's showing German in this particularly nice photograph we have here. It's one of the best analyzers in the market, we believe, for the money that's available, especially now. There's some discounts going on that we have going, plus some rebates from Testo, which will allow you to get into a complete printer kit for $900, which is a pretty hot deal considering last year is around $1,400. So there's a huge discount program going on right now for the same product. It's designed for commercial, light residential and light commercial markets. It doesn't have all the test gases or features necessary to do real full commercial testing, but it does get up there into testing, say, commercial systems that you'd find on larger boilers or burners. It's a commercial landscape like a restaurant or that type of situation. It's very easy to use. It's got a very long sensor life. It's warranted from the factory for 3 years for both the oxygen and the CO sensor, so you don't have any worries or concerns about the sensors dying on you for a good 36 months or plus. The menus are customizable, so you can get out of it what you want in terms of the order of the display, and we'll get into that in a little bit. There's field serviceable sensors. You can remove the sensors and install your own replacement sensors without the need for calibration. There is one hitch there. When they move to a new type of carbon monoxide sensor, the meter itself will require a firmware upgrade to version 1.14. If you do not have version 1.14 in your meter, you have to send it in either to TruTech or to Testo to get the firmware upgraded in order to use the new replacement sensors. You'll be free to use any sensors from that point forward, but it needs a one-time upgrade if your firmware is less than version 1.14. You might want to make note of that. It incorporates Knox filters. I believe we have a slide covering why that's important, but just the basic overview is, if you recall back to the slide where we talked about all those toxic gases coming out of the combustion system, nitric oxide gas is one of those toxic gases. It will actually trick a CO sensor into believing it is carbon monoxide gas to a certain extent. You need about 10 parts per million of Knox. It'll look like between 20 and 50 parts per million CO. Testo's incorporated an onboard Knox filter right into the sensor. That will make the Testo readings look lower to an uncompensated or an uncorrected meter. But when you're out to measure carbon monoxide, you're out to measure CO, not to measure CO and an unknown concentration of Knox that goes along with it. So it's important to have that. Testo's built it in as a filter into the front of the CO sensor. If you're familiar with the Bacharach brand of analyzers, Bacharach has now incorporated an outboard filter or filter cartridge that you can add to any of their products in order to kind of purify the CO level to read just CO, because their sensors do not have a built-in Knox filter. So you can get an external one. It's available from TruTech as well as under other vendors. We sell for about $49, I think. You can measure differential pressure with the pressure inboard pressure sensor that's inside the meter, and differential temperature between the two sensor probes in the unit. And we'll get into where those are located exactly. And you can print results with the optional printer. And again, we recommend printed results because they're a record. It's something you can have. You can give one copy to the owner of the equipment. You can keep on file for yourself. It's a good place to document what you've done, when you've done it, which meter you used, and what the readings and outputs were. And especially now with the pricing on these printer kits, it's a very good idea to get one now. The printers are universal. The Testo ones work on all the brands out there in the market. So let's take a walk around the outside of the analyzer. Going from the top, there's of course the power button. It has a 1-0 on it. It's a little one nestled in the top ledge of the product. The drain plug, which is used to, if you recall back, we talked about water vapor being present as a combustion byproduct. Well, the vapor will condense and form liquid water. The condensation, Testo controls it to happen in the back half of the meter inside a water trap that's built into the back of the housing. That occasionally has to be drained when the water level reaches, and we'll show you in a minute on a slide, the max line it's visible through a translucent window on the water trap. Just pull the drain plug partially out. It puts a little spigot sticking out, kind of like a beer keg, and you dump the water out just by tilting the meter. It's mildly acidic water. It's got about the acid content of orange juice, so don't worry about getting burned with it. It won't eat through clothing or anything. You can put it down most community drain systems. But be sure to close the drain plug. If you don't close the drain plug, you've just made a pathway into the meter for room air. And room air will dilute the sample and throw off all your gas readings in most of your calculations in the meter. So you don't want to do that. If you open the drain plug, make sure you securely close the drain plug afterwards. The display, of course, is a 4-line display. It's a backlit display with a nice bright white backlight in it, and we'll get into the configuration. You can see, you might be able to see line number 1, 2, 3, 4. Those are the line numbers. You can configure which parameters are brought up or shown in the display. So soft keys or function keys, we call them soft keys because they're based upon software commands. The corresponding function for the key is above the orange key itself in the little window, the three little boxes that are separated up here. In this case, the left key has no function, the right key has no function. The center key would serve to click OK or Enter in this particular screen. But because of the complex meter you have in your hand, but the relatively simple interface, you have these software keys which give you plain English labels instead of a multitude of keys to push. The up-down arrow keys allow you to navigate on the screen up and down to scroll it. It is a kind of a continuing scroll that goes around and comes back with all the different parameters in it that you set up into it. It can also be used as an adjustment mode. When you have to adjust numbers or settings, you can use the up-down arrow keys. So they're always used for adjustments. The menu key puts you into the various menus and submenus, which we're going to get into in a couple minutes. The escape key, of course, would back you out, so there's a graceful exit. Anytime you have some trouble, not trouble, but you just want to get out of the screen that you're in, just hit the escape key to back up. At the very bottom, in a little cage, is an ambient air temperature probe. This is a reference point for the meter to tell it what the surrounding temperature of the air is before combustion, so it knows how to make an efficiency calculation. But you can also remove this cage and put in an optional probe, which could be a clamp probe or a bead type probe, various types of probes that are used for measuring air temperature, surface temperature, and that kind of thing. That's where you get the differential temperature measurement out. But it comes standard with this little temperature probe, air temperature probe in a cage. The flue gas probe connection is this metal ferrule on the bottom. You can see kind of the locking ridge that's inside there. So when you place your hose connection up over it and you give it a twist to the right, it will lock it in place. Very secure connection with a lot of good strain relief on it. So there's no danger or worry of loosening the connections or losing contact when you're in the middle of making a measurement. The flue gas probe connects the pathway for the flue gases to get inside the meter to be pulled in by the pump and be analyzed. It also has the contacts for the temperature probe for measuring stack temperature, and it also has a pathway to measure draft when you use the draft test mode. Everything is in one single fitting. The fitting is also keyed, so you can only put it in one direction. There's no way of mixing up or confusing the connections. Next over is the charger port, where you'd plug in, and I'm sure if you've had your meter or you're looking at getting one, you can use the charger port to plug in and to either run the meter or usually more often to charge the lithium-ion battery that's inside. I believe you get about 5 hours of life typically, depends upon how you run the meter, but you get about 5 hours of life out of the one charge in the battery. The charge also displays on the screen the percentage charge when you plug it in, so you know how far along it is in the charging process. There's a differential pressure port also at the bottom that would allow you to take the minus side of pressure if you wanted to do some differential pressure measurements, as we talk about up here. The backlight key allows you to control the backlight on and off. Backlights do use up a little bit of battery, so you can switch it off at any point. With any key contact, the backlight will come on to let you see where you are, but then it will dim out after a few seconds, and you can always force it to go on, and it will stay on until you switch it off with the backlight key. So let's take a look at the side of the meter now. I talked about before the water trap. Here's that max line in the condensate trap or the water trap, so you can see if the water gets above that level, you have a chance of sucking the water into the pump. If you suck it into the pump, it could gum things up, so you don't want to let it go there. You want to make sure that the condensate never goes above the max line. Now the max line is designed in such a way that you could tilt it on its back, on its side, upside down, wherever. It doesn't matter. As long as it's below the max line, it won't be taken in to the pump system. But for sure, every time after you complete a series of measurements and you put the meter away, you want to drain out the condensate trap. We talked about some of these features before from the front, but let's take a look at them again. The power button has a 1-0 on it. It requires a momentary press on it, and then it will start the meter up. Inside this area here are the LEDs, which have the IR output for the printer. So it's a wireless communication with the printer. But because it's IR, it's a stream of light, infrared light. It can't be interrupted or broken. It's not really wireless, but it's like your TV remote. If there's something in the way, like the dog or the bag of potato chips, it's not going to work. The condensate trap, here's a top view of that. Plug says pull on it. Doesn't mean pull out. It means pull slightly out. You pull it out a little bit to allow it to drain, then you make sure you push it back. It's got a nice little kind of bib along the side, which allows you not to spill condensate back inside the meter. The charger port shown here, it's keyed. It's got a little lobe on the bottom, so the keying of the charger port, you can never confuse that or put that in backwards or sideways. The probe connection, this is the flue gas probe connection. You'll notice you might be able to see the inscribed arrow with the flat point. You want to line up the arrow that's also molded into the metal probe on the male side of the connection. That's the point you want to line up in order to key it correctly. This port here with the manometer plus on it, that's the hose that connects to the draft sensor, and the manometer minus is over here. There is an adapter available for this to do gas testing, or you could just slip a tube securely over the complete opening at the tip of your probe if you wanted to access and run a pressure test with the plus side of the manometer. The combustion gas inlet, the combustion gas inlet is over here on the right, on the left, and the exhaust vent. After the gases have been consumed by the analyzer, analyzed, they're pumped out here up the bottom of the meter. And then this removable ambient air temperature probe we talked about before stays in the meter normally. It can be replaced with another temperature probe if you so desire. Now let's take a look at the back of the meter. Before you peel off the battery door here on the left, you can see there's some very strong magnets. I was unfortunately the victim of strong Testo magnets on my PC once. It literally crashed the hard drive. These are so strong, they'll pull the right heads right up and crash into the media. So please keep it away from credit cards, cell phones, computers. These are industrial strength magnets. But they do hold the meter up nicely in place, inverted sideways under some minor pressure and strain, so they'll keep it in place for you. So there's two at the top and one at the bottom that's hidden inside the battery door. This is the access cover to get inside, and you can see the manufacturer's label here, which includes data on the model number of the meter, serial number, and date code. Sometimes those are necessary for service aspects. They may also be necessary, in fact, I believe, to claim the rebate. You may need some of those details and information for this rebate that's going on right now. So it's just good to know where your information is in terms of how the meter was put together at the factory in Germany. The pump here, once you remove the battery door, there's two Phillips head screws and a little lip that falls under a groove inside the top part here. Once you remove that battery door, you'll see inside the pump, just user serviceable, but almost never needs to be serviced. It's a very rare service item. It's the way they've got it filtered and protected. The pump just keeps running for years. If we follow going down here on the left, we have the lithium-ion battery, which is replaceable if necessary. I haven't heard of too many battery replacements in the course of 4 or 5 years. You may need one maybe in 5 or 6 years. But the battery, you push your thumb in the slot here where the arrow is and then slide down. It would release the contacts of the battery. To put it back in, you lay it in the tray and push it upward to lock it back in place. Pressure sensor is here just for reference. There's usually no need to service or do anything with the pressure sensor. The oxygen sensor here is a white sensor at the top. That is one of the replaceable or user serviceable sensors. It's got a simple plug you can see just behind it here. It's a little connector. You may need needle nose pliers to pull it out, but you want to make sure that you hook it back up from the outlet of the pump. You want to hook it to the inlet of the oxygen sensor and make sure it hooks up to the bridging tube that goes into the CO sensor, and then the CO sensor goes into the exhaust port. So the flow of gas is basically over oxygen, over CO, and then exhaust. So it comes in through the bottom of the meter, goes up through a series of channels into the water trap where the condensate's knocked out, pulled into the pump, exhausted by the pump, over here to the oxygen sensor, then over to the CO sensor, then back out the meter. So that's the path through the meter. The CO sensor is also replaceable. They're also covered by the 3-year warranty on both the O2 and the CO sensor. The CO sensor has a Knox filter built in. It's a bit like a bayonet cartridge in the top of the meter, and I think we have a photograph of that in a second to show you what it looks like when it comes apart. I don't see any hand. I have a question. Sorry. Oh, the question was, can we record this? The answer is yes. I just saw the question now. So I'll get rid of that question. And another question I have is, would I touch on the 330 unit? Unfortunately, we don't have that available at this presentation here. So I would have to, we have to prepare one on that, which we have in the works. So we'll let you know. We'll advise everybody in our database. Now that you've attended one seminar, we'll be sending you newsletters periodically, but we'll advise you when a 330 version is available. And I apologize for missing these questions before. How do you tell the firmware version? Again, sorry about missing the question. Firmware version can be viewed at the startup screen. Right after you start it up, it'll say near the top of the screen V and then a version number. So that's how you can tell what's going on there. And other question is, how long do the sensors last, especially if seldom used? Do the units have something that indicates a need for replacement? Yes, there is a smart process inside the meters which will tell you when the sensors are approaching the end of the service life. And how long do they last? I would say you can get between 3 and 4 years out of an more than 3 years, but into the 4-year, 5-year period out of an oxygen sensor. And a CO sensor could last a good 5 to 6 years. The usage of the meter doesn't usually affect, unless it's really hard use, it doesn't usually affect the quality of the sensors or how long they last. It's usually more about just degradation. The oxygen sensor is pretty much like a battery. It has a liquid electrolyte in it that reacts with oxygen in the air. And once that liquid electrolyte is all consumed, the various constituents in it are consumed, then it's no longer going to be functional. So it's got kind of a combination of shelf and usage life, but it's in there in the 4 to 5 year time period for how long it would last. The CO sensors usually die because they dry out. They have, again, a liquid electrolyte in them, but the Testos are designed with such good sealing practices and processes in them, you're probably looking at 6 years of service life out of them. Okay, that clears the questions, and I'll try to be more attentive to that as we go along here. I'll put the window up in my corner. So please continue to ask questions. This works great for me to be able to answer them this way. Okay, here's the picture of the CO sensor with the Knox filter. This is what it looks like. It's in this little bayonet coupling that sits above the red sensor. This is the filter block itself. Basically, we advise you should never measure CO without a Knox filter. And it lasts pretty much the lifetime of the CO sensor. And without it, you can get errors in the range of 40 to 80 ppm or higher as possible. So it's really something that you have to pay attention to, that you do use a Knox filter when you do CO measurements. So let's take a look at what the main menu provides. There's a measuring menu. When you hit the menu key, the first thing that pops up is a measuring menu. That's where all your tests are performed, and there's sub-menus in that, which we'll get into. There's the adjustment menu, where you can make changes for field or factory calibrations. Okay. Something funny just happened on my screen. I want to make sure everything is okay. All right, we're back online here. Setup mode for configuring the analyzer. I'm really glad we're recording this too, so they can, all my little flubs and fluffs can be viewed for all of history. The setup menu where you can configure the analyzer and put in the correct order and the correct parameters, units of measurement you want. If you want to measure in inches of water column, if you want to measure in pascals. Yes, I just got a question here. Does the 330 have graphing capabilities? Yes, it does. It has on-screen graphing capabilities, and that's some of the features that we would be covering in a 330 session, but not in this session here today. You can make the fuel selection as one of the menus in the screen, but usually that comes up when you're in the warm-up mode, so you would see that anyway. And the diagnostic mode for troubleshooting any functions of the meter. It would tell you what sensors, what kind of error codes have been logged. This is part of that smart process that the meter has built into it, so you can share that with whoever you're taking your unit to for service, or make a phone call to them to ask them what's happening in the meter. If I'm not mistaken, it also has the ability to print out the error screen, so you could actually, you don't even have to tell somebody what it is. You could fax or scan it over to them. It would print out all the error codes. You could send it right to the printer, the optional printer. So let's take a look at what's inside the measuring. Let's take a look at what's inside the measuring screen. The measuring menu has a series of different submenus in it, and they all wrap around. So here are the standalone tests that are made by the 327. There's the flue gas test, the draft test, the CO air-free test, and if you're not familiar with or you'd like to learn more about CO air-free, again, that's more of a technical topic that we will cover in the Combustion 101 session. Smoke or oil derivative, but I understand in the latest firmware that may have been changed. Differential pressure measurement, and if you notice the highlighted or the boldface type here is what you'll see actually on the screen of the meter, and in some cases you see a small abbreviation like diff press. That was what you'd see in the screen, but it's basically showing you that there's pretty much plain English menus inside the meter. Delta temperature, which is the difference in temperature between the two probes, and ambient CO. The reason why there's a flue gas test, which includes a CO measurement of CO in the flue gas. There's also a CO air-free test, which is done separately, usually on unvented combustion appliances. And there's an ambient CO test, which is done for the background CO. They all use the same sensor. It's just more or less you're keeping track in a notebook when you store these tests away. Every time you take a test, it's stored in a temporary notebook type file, which could then be printed out with the combustion record. Since you will have a difference, hopefully, between the ambient CO, the CO air-free, and the flue gas or the stack gas CO. They all be different numbers, but you need to have them labeled to make it a very comprehensive report. And again, they'll either come back up in the meter if before an on-off cycle, or you could print them out. So the flue gas covers the properties, both the measured parameters and the calculated parameters that are present in the flue gas. When we talked before at the very opening slide and we showed those bubbles with the different combustion parameters, oxygen, CO, temperature, those kind of things, those are all the parameters that can be measured in the flue gas mode. There's a question here, does the 327 measure smoke? The answer to that is no, it does not actually measure smoke, but in this case what they provided is a place where you can enter in the smoke number that's measured. If you use an external smoke meter, either a digital smoke meter or one of the manual smoke pumps, and then it can become part of your printed test result. So this is just, it's not a measurement mode so much as just a place to keep track of the smoke you measured through another parameter, through another device. Okay. The draft is a measurement of the pressure in the stack with reference to the combustion air zone pressure. It's a differential type measurement. It's a stored value that would be automatically stored after you take the test, and then it would be available in the printout. I keep on making reference to the stored values, the notebook, that kind of thing, because the 327 does not have an onboard memory. So any tests you do in it are available there on the screen. If you do another of the same type of test, it will write over that data. But every time you do a test, it's stored, and then when you do a printout, everything that's available will be printed out in that test record, everything you've selected in your setup screen. And by the way, the setup screens are designed with factory defaults in them, which you can always go back to. So if you ever feel you've messed something up or you've gone too far astray, you can always move it back. Or you can just give us a call, 888-227-3437. Excuse me, 888-224-3437. That's what I said. You can just give us a call, and we will help you get your meter back in correct operation. The CO air-free measurement is a measurement of the ambient CO with reference to the oxygen that's still available in the flue gases. This is typically used with ovens or stoves. That's like an unvented appliance. And again, this is a stored parameter, which means it gets put away until you do the printout or you run the next test. Smoke or oil derivative. We're going to explain what the oil derivative is a little bit later on, but it's as a user input of the smoke spot number coming from a manual or a digital smoke meter. Differential pressure is a pressure measured between the stack probe and the pressure port, those two ports at the bottom. And as I mentioned before, there's also an adapter for static pressure for doing differential or combustion air zone or static pressure measurements, say if you wanted to determine static pressure in a ductwork or a static pressure differential over anything in a ductwork through a heat exchanger over an air conditioning coil. Delta pressure, or excuse me, delta temperature is the difference between the stack probe and the thermocouple. This is also sometimes called net stack temperature. It's used automatically in the flue gas mode, but it's also available to be used if you want to measure, say, a difference in a hydronic heating system between the two temperatures, or the temperature rise over a piece of equipment or temperature fall over a piece of equipment. Got a question here, is pascals available in differential pressure? And yes, it is. When we get into the screen setup, I'll show you how you can change that over. And ambient CO, that's the just the typical ambient CO measurement in the breathing air. Again, that's a stored value in a special location that'll come up ambient CO on your printout. So doing a draft test, it's important to know a few things about how the meter responds and also know about where to do the testing. Again, we cover this a little bit more in depth in the TruTech training. Question came up for differential pressure. Why does one need a different probe? You don't actually need a different probe. You can just slip a hose over the minus pressure port and then a tube or a hose over the flue gas probe end, making sure you fully cover the end of the probe tip. And you just need the hose in order to access the pressure zone. If that isn't clear, I could talk with you offline about this issue. We might cover it in another slide, but please remind me in the end if this isn't a clear answer for you. When you start up a draft test, there'll be a 5-second period where the draft sensor is zeroing out, and this is true for any of the pressure tests. You have to make sure there's no pressure on the sensor, and the probe is out of the stack, and the hoses are still not moving, because even a small amount of movement in the hose will generate a pressure, and that would cause your zero to be off. And as you can see here, we do have Pascal measurements shown on this screen, and I can show you how you can set that up on your analyzer. The draft test also has a kind of a unique feature here where you can find the hotspot in the stack where it shows you the temperature that the max temperature you've seen, which would be the little tag or T or this arrow mark here, and then the current temperature that you're reading. And then the graphic tells you if you've reached a new level or you found the hottest spot in the stack. The reason for finding that hot spot in the stack, it provides a repeatable measurement location So the next person doing the test can receive the same value, because draft does actually vary. Again, it's not a perfect world. There's a lot of variations. There's a lot of turbulence, a lot of chaotic airflow inside any part of really a heating or cooling appliance. So you have to have some kind of frame of reference, and this hotspot indicator provides you with that frame of reference. The draft test, if you had, this is showing a dilution thimble, but to give you an idea just of the importance, it's a kind of clear an illustration. You'd want to do, you have the undiluted flue gases coming up, and you'd want to do the combustion test before dilution if you have an atmospherically vented or a dilution air type system. Because if you did the combustion test afterwards, you would be seeing values that are diluted and not representative of what's going on in the combustion process. It's kind of like putting a lead plate across your X-ray subject. You're not going to see much if you've masked it with dilution air, because so many of the gas parameters depend upon their concentration. So if you've added dilution air, you've lowered the concentration and really fuddled up the flue gas reading. However, you do want to take the draft test above where dilution air may enter the system, because that's going to be the air, the parameter, the pressure parameter that's pulling on, providing the negative pressure that creates the airflow through the combustion system. So it's two important distinctions. If you have a dilution air system, that you do the combustion test pre-dilution air, and you do the draft test post or after dilution air. The CO air-free parameter, again, is used in oven stoves and pretty much in vent-free appliances. This it's actually a calculation used with the CO and the oxygen sensor, and it won't start calculating until it drops below about 18% oxygen. So if you're trying to measure CO air-free and you see dashes, you're really not in a combustion zone. You're so diluted with excess air, with excess oxygen, it's above 18%, that there's no calculation possible. But when you do get to a point where you have below 18% oxygen, it will start making a calculation of the CO air-free. And this big red arrow here notes that the 327 should be zeroed in fresh air or outdoor air prior to starting this test in order to get a background level on oxygen and calibrate itself and get a calibrated level on a CO, the zero level of CO reference. If you press the startup button and it goes through a countdown cycle where it's saying calibration and you have the probe in the stack, all your readings are wrong or incorrect. You have to make sure the first time during a power cycle that you power up and go into combustion test mode that the probe is out of the stack and it's breathing as fresh air as possible, outdoor air or fresh indoor air. Just going to check the list here, make sure no one's got a question. Okay. All right. Smoke or oil derivative. A smoke test, again, can be recorded in this screen, but it's done through another device, either a manual smoke tester or a digital smoke tester. It can be recorded on this screen, then an average will be developed. You could print it out from the screen or store it to be printed with your whole combustion test. You can do multiple tests, up to 3, and it will give you an average. And this oil derivative is commonly used in testing in Europe. And you just simply insert an answer yes or no if you saw a spot develop. Basically, it looks for raw fuel being blown through the system. It's not a test that's done in North America that we're aware of. Here's a hang on one second. Got another question here. Okay. I'll stop here for a second and answer the question. The question is, are we supposed to send the unit to Testo if we're on a firmware version earlier than 1.14, or can the update be done without sending the unit in? Unfortunately, the unit has to be sent in to someone that has the calibration fixture from Testo. TruTech and Testo, that we're aware of, are the two places you can get it done right now. The firmware update's not going to improve or fix anything. It's just going to allow you to use new replacement sensors. So there's really no upgrade in features or functionality. It's more about the ability to use a replacement sensor. If you don't have the upgrade, you can't use the field replaceable sensors. So it's a hurdle you got to go over once before you do any sensor replacement. And TruTech and Testo are the people that can do it right now, and it has to be done by sending it in because it requires basically a factory type fixture in order to provide that programming. So here's on the oil derivative. If the heating oil is not burned completely, there'll be oil derivatives or raw fuel being passed through the system. Oil derivatives are organic substances, and by putting a dropper of acetone on, you can see them develop. Here's the process for doing it. Again, this is more or less I say top secret, tongue-in-cheek. It's something that people don't know about here, basically because it's not required to be done. Also got another question coming in. How much does the firmware upgrade cost? Right now, TruTech is doing it for free if you send the product in on your own postage, and we'll send it back on our postage on our dime. So you just have to contact us for a free upgrade. But again, the upgrade's not necessary unless you need a sensor replacement. So if you get it done beforehand, you're just getting yourself ready, but your analyzer will be out of service when you send it in. So as long as you pay for the incoming postage, TruTech will pay for the postage back or the shipping back. So you can just contact us for that, and I'll make sure our customer service is aware and fluent with this type of offer that I'm making. Can someone use acetone-based nail polish remover for the oil filter test? I guess yes, if you wanted to, but the reported value you get out of it, frankly, no one's interested in. So you could do the test, but I'm not sure. But it relates to a European standard that isn't enforced or even well aware of in the U.S. So I'm not sure what you would do with that information. Differential pressure, either with or without an accessory adapter. And here's a little star. You can simply slip a hose over the end of the probe, covering all the slots instead of using a pressure adapter. But you could get an accessory adapter to do differential pressure tests, to record the pressure drop across filters, heat exchangers, pressure switches, coils, any kind of device. Again, it's important to make sure that before every test, any pressure test, there will be a zeroing or a quiet period, which you have to have no pressures on the sensors, the hoses out of the stack, across no pressure references, and still in order for that 5-second countdown. Then when you press the stop button in the corner, lower right-hand corner, it would be the reading is recorded and stored for your subsequent printout. Question comes back up on the oil derivative. It would indicate unburned oil. Yes, that's correct. It would indicate unburned oil. If you want to send me an email afterwards, I could send you the European standard, and you can see if you'd like to use it. I'll try to dig up information on that. So you could just send an email to bill@TruTechTools.com, TruTechTools.com. This is from T. Hardy, is the asker of the question. Just send me an email, and I'll send you over some details on that. Another question comes in, is there any reason why you would not use the sensor to measure gas pressure? No reason at all why you would not use it. You can, in fact, we provide a little pressure accessory kit where we've put together a static pressure probe, some super flexible, resilient silicone tubing, and a 1/8 male NPT that has a hose fitting on it, so you could screw it into the top of most manifold regulators to be able to measure the gas pressure in a system. So that's a very good question. No reason why you couldn't use it for measuring gas pressure. The delta temperature screen allows you to measure any types of differences in temperature. Here, the little probe in the cage at the bottom is one socket. Underneath it is one socket for the temperature probe, and then whatever's connected to the flue gas probe connector is the other one. In this case, you pretty much need to have the adapters to do it, or an accessory probe to conduct this measurement. There is a temperature probe adapter that would screw into the flue gas fitting, and these are custom probes from Testo with a special fitting on it, a circular type connector that goes in. If you're interested in that, you can either drop us a line or give us a call, and we can present that information to you about accessory probes for differential temperature measurement. The Ambience CO test is used to measure basically CO in the breathing air. Again, the 327 needs to be zeroed in fresh air if this is the first type of combustion test during a power cycle. And a power cycle is power on, power off. In between the two power on and off is the power cycle. In other words, things reset in that power cycle. So if you've been running it doing another type of test and you've already zeroed it and you move on to an Ambience CO test, it won't ask you again to refresh and to do the zeroing again. But it will happen if it's the first test you do during a power cycle. We recommend using the stack probe during measurement just because you can get it into and around. You can hold it in the ambient air at a distance away from you rather than just to make sure that you're taking a measurement, you know where that measurement's coming from. If you notice over here on the left, there's a little icon with 4 bars on it. That basically indicates that the pump is running. You may be in a situation where you can't hear the pump, and if that's the case, you can tell that the pump is running. It has power to the pump by the fact that the bars are moving upward. The 4 bars are moving upward on the side. When you press stop, it records the reading you've taken, and it labels it with the CO ambient parameter and measured in parts per million. Okay, we'll go through the flue gas measurement test. We'll just kind of enumerate what's available on the screens. These are all the options you have. And again, just stress one more time, the 327's got to be zeroed in fresh air before starting a combustion test. First parameter you can grab is stack temperature, and it can be in degrees Fahrenheit or degrees Celsius. Oxygen, that would be in percent by volume. Carbon monoxide, usually measured in parts per million. There are other parameters available, but they really aren't used in our industry here. They're more used more in the emissions industry. Carbon monoxide air free is another parameter that you can pop up into your display. And by the way, anything you pop up in your flue gas measuring display, this is the order that you can move the order around. You can change the order. This is the order that comes up as standard at my last check. But you can move the order around and place any of these parameters that you want in the screen in any order that you wish. Whatever you put on the screen is what will appear on the printout. So that's something to keep in mind. When you configure the screen location, you're configuring the printout list. Percent efficiency is the next parameter. That's the combustion efficiency. The excess air, which is another calculated parameter. And by the way, you can switch any of these off. If all you wanted to measure was oxygen and CO, for example, those would be the only 2 things on your display. You could switch everything off. And you haven't permanently deleted them, you just switched them off. So they're not available on the display, not available on the printer. You can go back in at any time and reactivate those and put them in any order you want. Some people have times where they test the first, since you see 4 on a screen, these might be your top 4, and these might be your next 4, because you do testing in different ways or different modes. So you just merely make a scroll up on your screen, and you can get your next 4 in line. You could even repeat. If you want to have stack temperature, oxygen, CO, CO air free, and then CO, excess air, pressure, and draft, you could have those in the second set of screens. So you could repeat any one of these parameters. If you really wanted to get crazy, you could put CO and all lines on the display. It won't come out on the printer because the Germans are conservative and they won't waste paper. but it will come up on the screen as many times as you enter a parameter on the screen. So dew point temperature, that's a calculation based upon the fuel that you're burning. And draft is another parameter that can be measured, that can be shown on the screen. Sorry, I had to take a sip of water here. Ambient temperature is another parameter you can bring up. That would be the temperature that's measured by that little temperature probe inside the cage. Instrument temperature is a temperature that's measured inside the core, the body of the instrument. Not exactly sure why you'd want that as a measurement, but it's available. Question came up, how is dew point temperature measured? Dew point temperature is not measured. It's a calculation based upon the type of fuel. The assumption is made the fuel, if it's a natural gas or propane or oil, that the makeup of the fuel controls its dew point temperature based upon the chemical makeup of the fuel. So it would tell you the current dew point temperature for the fuel that you're burning. That might be interesting if you're looking for issues where you have a condensing system or a system that isn't supposed to be condensing, but you may get below the dew point temperature. When that happens, then there's the chance that you could get some of that acid gas to rain out of the flue gas and cause some issues inside either the equipment or the vent system, the chimney, etc. But it's a one number for each type of fuel that you're burning. And somebody I think is giving us a pat on the back here. Dog, this is good. Thank you. Delta temperature, that's the other parameter we talked about, how you make the measurement. This is one of the things you can bring up on the screen. Differential pressure again, ambient carbon monoxide. And now we'll just get into a quick definition just to make sure we're all oriented here of what and again, you'll get a copy of these slides. Stack gas temperature, that's the gross stack temperature, which is the ambient temperature plus the rise in the stack temperature. Oxygen, which is the percent of oxygen left in the flue gas after combustion. If you go back to that slide where we showed you how combustion works, and you have incomplete combustion, which is normal in the world, and you have that oxygen on the other side of the equation, that's the excess air that came through. That actually is a little hint to what's going on in combustion, so that's a look-see into the combustion. Oxygen is a measured parameter that's used in a couple of different calculations for the meter. Got a question here. Are all the 327s, that is the older ones, the same or upgradable? The 327s are all upgradable. It's just that you need to have the firmware upgrade in order to use new replacement sensors or the currently available replacement sensors. So if your firmware is 1.14 or above, you're all set. You could get those self-service kits. If it's below that, you have to send it in for a firmware upgrade in order to use it. But any Model 327 can be upgraded. The carbon monoxide is the raw measurement right from the CO sensor here. It's what the CO sensor sees. It's not corrected for dilution. CO air-free takes into account the dilution by the excess air. It uses also the oxygen sensor that's present. Efficiency is the appliance efficiency that's taken into account. We talked before about how it's calculated. We get into a little bit more in depth. Anytime you see this little TruTech training logo down here, that's a reminder for us to tell you you should consider going to the Combustion 101 session where you get a lot more in depth on the kind of the technology. It's not about the meters or the equipment so much, but it's more about the technology and the science behind it. So it's applicable to any brand of analyzer, our Combustion 101 session. The excess air, that's the percent of air that's gone through the combustion process without being consumed. Again, when we talked about the imperfect world. And I'm waiting for my screen to respond. Okay, dew point temperature is the calculated temperature at which the flue gases start to condense. We talked about that before. It's one number for each different type of fuel. But it can bring it up on the screen if you're interested in seeing what your current stat gas temperature is compared to the dew point temperature. You'll know if condensation could be happening around the point that you're taking that measurement. So some of the other parameters we'll talk about that were inside that list of parameters you can set up: the draft reading, the ambient temperature reading, which is the temperature of the combustion air zone, the air going into combustion, internal temperature of the instrument, the differential temperature between the two temperature probes, differential pressure between the two pressure ports, and the CO ambient, which is the level of CO which is measured in the air directly. Got a quick question here. Is the excess air same as the CO, is the O2? Excess air involves what type of fuel you're burning. They do go hand in hand by an equation, but it depends upon the type of fuel. Oxygen is a measured parameter, so it's what the sensor sees. If you have an oxygen level and you look at a certain fuel, you can then say what the excess air is. So they're similar, they're related, but they're related by the type of fuel you're burning. That's why it's important to select the right fuel when the meter asks you to, and to look in the screen and make sure you're measuring with the right fuel. They're not the same thing, but they're related, and they're related through the fuel. Another question: what is the equivalent firmware upgrade for the 330? The 330 is a different animal. It actually is firmware upgradable via the internet. If you go to the Testo service and downloads page, I believe you can actually download for free a firmware update tool. You can download the latest version of firmware for your 330, and you can do the installation all by yourself. All you need is a PC, a USB cable, and your 330. It can all be taken care of by the end user. It's a little bit more expensive meter with a little bit more sophisticated programming in it. That's why you can do it over the internet on your own. The adjustment menu, we say, is pretty much reserved for factory authorized or service center. You can make adjustments on the CO, the O2 cal. We are in the process of starting up a calibrations and service division at TruTech. So that's one place you can get some of this done, and definitely at Testo. And this is a picture of Testo's building in Germany, in Lenzkirch, Germany. Beautiful building, all glass surroundings on it. A very interesting building. But Testo is serviced currently in the U.S. out of Sparta, New Jersey. That's their sales and distribution center, which is really kind of our key point of contact for Testo nationwide or across North America. So they're at 800-227. Oh boy, I'll have to send you the number later when I figure it out. 0729, I believe. 800-227-0729 is their toll-free number for Testo service, and TruTech, of course, is 888-224-3437. Again, I'm glad I'm recording this. The setup mode. Here's where you can configure the display. Again, we're working down through the major steps in the main menu system when you press the menu key. The next one we're going into is setup mode. It's got 3 sub-menus. One is for configuring the display, one is for setting the date and time, and the other is for adjusting the language. At this point, it can be configured. The 327s that end up in North America, it is a worldwide product. It's been on the market for several years. It's in Chinese, Czech, Polish, Japanese, any kind of language you can imagine. There's a 327 cousin somewhere in the world. It can be configured for English or French, and that French is for French-speaking parts of Canada. We only support the English-speaking, but we can tell you if you accidentally flip it into French, we can help you figure out how to flip it out of French. It's you basically go into the setup menu, but because all the language cues will be different, it's going to be a little hard perhaps to get there. So give us a call if you actually accidentally flip your meter into French. We can switch it back to English in just a couple of seconds. So the first item you come into in the setup menu is the display mode. It allows you to configure what you want to see on the display. You can, like we talked about before, you can organize it the way you want to. You can eliminate measurements that you don't use at this point. You could always reactivate them when you do choose to use them. And it also sets the order of the screen on the printout. The order on the screen sets the order on the printout. I'm getting another question about the dew point function on the 330, which I'm not prepared to answer at this time with this presentation. So if you want to give me a call afterwards, we can talk about that. When you go through the display setting, you'd basically indicate which parameter you want to change on the display, and you would scroll down to the parameter that you want to change, and that line would then flash. The number on it beside it would flash in the corner of the screen. You would then press the buttons at the bottom to change the parameter and use the up and down buttons to scroll through and pick which parameter you wanted. Then there's another button on the side which says units, and that units button would allow you to choose which unit of measure. So that's where you could switch from inches of water to Pascal. And once you've selected your changes and your display order and the parameters you're measuring, you just have to be sure to remember to scroll down to the very bottom where it will say Save Settings, and you press and enable it to save settings, and at the top across the screen it will say Info Accepted. Only when it says that have you made the changes. If you don't have that message coming back to you, you haven't made any changes on the meter. I'm making note here we should really have a little bit more detail on this process. So in future presentations we're going to cover a little bit more detail because it isn't that straightforward that you could perhaps understand it verbally. So we'll try to take care of that with an upgrade to our presentation. The next parameter is, and also I apologize for going a little bit over time here. The next parameter is the date and time setting, where you can set the date and time. Again, we're going to put some more slides in for that one to make sure it's crystal clear on how that's set up. But if anyone's familiar with any type of electronics, the menus and screens are pretty straightforward with it, but it'd be nice for us to show you a screenshot. And then we covered the language issue. The next screen is fuel selection, and that's where you can pick which fuel. These are the current fuels that are available inside the Combustion Analyzer. Natural gas, and these are the order that they go in, the sort order as you move down the screen. Natural gas, Bioheat 5, which is a combination of 95% fuel oil number 2 and 5% biodiesel. It's currently an approved fuel by, I believe, all the oil heat manufacturers. Propane is the next fuel, oil number 2, oil number 5, oil number 6, and then getting into kerosene and wood. Those are the different types of fuel. These fuel selections will help the meter make the correct calculations for some of the calculated parameters. So you want to make sure this is correct. The fuel selection will appear on the printout, and you want to make sure that you have the correct fuel selected. It's also at the top of the combustion analysis screen to make sure you're prompted in the correct mode. You can always change it on the fly, but you just want to make sure you have the correct fuel set, bottom line. In the diagnostic mode, that's I believe the last menu that's available in the menu screen. You have 3 submenus: info, error, and battery. The info screen, here you would get the model and serial number of the meter, which is electronically embedded in it. It's also on the back label of the cover that we talked about before. It will also tell you the instrument temperature in degrees Celsius, which is important when you're doing some diagnostics and troubleshooting. The technician may ask you that. Then the number of hours of runtime. Getting a question about The wood selection, there is an expanded fuel list on the Testo 330 where it does get a little bit more refined, and it accounts for the moisture content of the wood, which does affect its combustion property, which you can get, that's available on the 330 series. A little bit more advanced analyzer. I think it has about 18 fuels in it versus the 8 in the 327. So you do have a little bit of expanded capability with the 330. The error screen provides information on errors in the meter. It has a 2-digit number that comes up, and you can contact service. At this point, if you get a device error like that, you can contact us, but most of the time we'll recommend that you talk to Testo directly. This is a little bit more elaborate of an error code function than we're currently set up to handle. The battery will show a nominal voltage of 3.7 in the battery diagnostic screen. Gives you a runtime about 4 hours and a fully charged time about 5 to 6 hours. Some inside info here. The meter itself tracks the running time. There's it's like on some farm tractors where they have an hours running meter, so it tells the hours of time that the pump has been running, which again gives the service department an idea of how much function or how much use the product's had. And it also has a sensor overrange feature that can be read by factory authorized service to tell if a sensor's gone into overrange. And unfortunately, if you overrange your sensor too much, you can damage it. And because it was a willful act to overrange it, most of the time it won't be covered by warranty. Question I got here: can the meter be operated when charging? The answer is yes. So just a little bit on service and maintenance of the meter. You want to take care of the meter, which if you take care of the investment you made, it helps you perform and get the correct results. We recommend calibration about once a year. That would be calibration mainly for carbon monoxide. Most of the other parameters in it, temperature, pressure, and even oxygen are not calibratable. The oxygen is a reference that's always done when the meter starts up off of room air. Service that may be required are pumps, filters, and probes. In the case of the 327, there is a filter that's in the end of the probe. It's a yellow cone type filter. It's made of a plastic breathable polymer, and it's yellow in color, and that cone will get dirty when it gets contaminated by any kind of soot or dust. When that's discolored, then you want to remove that filter and replace it. Every meter comes with 10 new filters, so you're set to go for quite a long time. There's also maintenance of the probes, where you want to make sure that the probes are taken care of in terms of, hang on one second, got to get another sip of water. The probes are taken care of in terms of being kept clean and free of any kind of debris that could get sucked back into the pump system. Got a question here: can the 327 or 330 be used as a gas leak sensor for the gases tested? It doesn't have, either of the meters do not have a built-in combustible gas sensor, if that's what you mean by gas leak sensor. Combustible gases are like propane, methane, natural gas. The 330 has an optional probe that can be plugged into it to be used as a gas leak sensor, but frankly that probe is way above the cost of an equivalent standalone type meter, and I wouldn't recommend, unless you're really motivated to get one, it's better to get a separate device rather than a connectable probe. I think it's about $330 where you can get a standalone gas leak detector for about $195. That's a very good quality and uses the same kind of technology. Storage temperature limits, you want to be careful because we talked about water vapor that's inside the flue gas, and that the flue gas makes its way throughout the meter, and that water can condense. And when water condenses, if it freezes, it gets below the freezing point, it can cause damage, mechanical damage due to ice buildup. So you just want to be sure that that there's no that you both empty your condensate trap, and you do not store it in sub-freezing temperatures. The testometers do have very good protection against that. Some very good membranes that cover the sensors to keep water from getting in, but I still wouldn't mess with it. If you can take it in on a cold night, you should take it in. Fresh air purge. The meter actually won't shut off, even if you've turned it off, if there's excess carbon monoxide or low level of oxygen sensed on the sensor. It will continue to run the meter until it gets it below a certain point, and then it's satisfied that it can be shut off, because you don't want to put it to sleep with carbon monoxide that it's still inside the meter touching the sensors. The sensor range for carbon monoxide, that's something that you don't want to go into the overrange condition. I believe it's 4,000 ppm for the 327. You can effectively go about double that for very brief periods of time, but you don't want to go there. There is an automatic overrange protection. I believe in the 327 it's set to about 3,700 ppm, where it's automatically going to shut off to stop it from bringing in more and higher levels of gas. But when it shuts off, the gas is trapped inside. So you want to get it back into fresh air and purging again on fresh air. CO can kind of make the instrument sensor drunk, and you can give it toxic levels where it actually won't be able to respond afterwards on very, very high levels of CO for long periods of time. When we go into our combustion analysis seminar, you'll learn a little bit more about CO production, concentrations of CO, and how a sensor works. Basically, you want to take care of the batteries, and this is just in general for any combustion analyzer, but make sure you're using the right type of batteries. The 327 uses lithium-ion rechargeable in a custom pack, so it's hard to put in the wrong battery. Power supplies, it can charge and run off the power supply, charges the battery as well as runs at the same time. We talked about cold storage and the impact on the condensate, but it also has an impact on making the LCD displays a little sluggish and slow to respond. That's usually not a permanent failure or defect. They'll come back after they warm up a little bit. Batteries too can have a little bit of depressed performance when they're very cold. Again, so you don't have to baby the meter necessarily, but do take it in when it gets very cold. The case that they're packaged in does have a lot of foam padding in it. It is actually protective, so it can, for a truck ride or for out in a day with the truck or whatever in a very cold environment, it will protect it, but you do want to bring it back in overnight. The analyzer body it's not, it won't melt, but you definitely don't want to put it into contact with any kind of hot surfaces, anything hotter than you would touch. So treat the skin of the meter kind of like the skin on your body, nothing above 150 degrees, so that it doesn't get affected or begin to melt or deform. The probes themselves, the typical probes go up to about 1,000 to 1,200 degrees Fahrenheit, which will cover most of your testing operations. The question, should one run the self-diagnostics routinely? There's no need to. The self-diagnostics can be run if you wish, but the meter will report to you if there's any problems. And I think this may be again in reference to the 330, which we're not covering today in the presentation, that has some different features in self-diagnostics. Here's a picture of the filter that we talked about a little bit before, but this is the filter. This is actually from a different meter, but you can get an idea of what that looks like. The filter itself, the active area, is above this line, up and to the right of this line as we move this direction. The bottom part doesn't see any kind of airflow through it, so this will remain a bright yellow color, and as this begins to get dingier and grayer up through here, that's a signal to change the filter. So you can simply remove the filter cap at the end of the probe. It's a bayonet type clear window, and pull the filter out and examine the base of it to see if it's bright yellow and the top is gray, then that means it needs to be replaced with a new filter. When you do empty the condensate or the water trap or the particulate filters, you have to remember about the air tightness issue. Make sure everything's sealed back up again. Otherwise, you let ambient air into the system, and then that causes an issue with the air gas measurements. Thermocouples. You want to make sure you do not overrange or max them out. Be careful of mechanical damage or dinging to them. The strain on the wires and the plugs is kind of overcome in the 327. You can see here pretty clearly the arrow and the arrow on the base here. That's how you line up and you place them together. Because of the metal junction and all the strain relief behind it, it does keep everything in pretty good condition for a long time. Hoses, overexposure and temperature, cracks or holes or leaks. These again is for any type of combustion analyzer. There's really not too much to worry about in the 327 because of the single hose assembly with the really tough over casing. It's almost impossible without using a Sawzall to get a crack or leak in a 327 hose. We talked about pumps a little bit before. Basically, in the 327, you're not going to have too much worry at all about its pump. It is replaceable, but there hasn't been an instance at all that I know of any kind of pump replacement over the course of about 6 or 7 years the product's been available. Printers either use fresh batteries, or in the case of the new Testo printers, they're rechargeable. You want to make sure you load the paper correctly. Usually the instructions have a good, straightforward way of showing you how to load the paper. Using since it is thermal paper, it can fade to black under really high temperature exposure, say on a dashboard or inside a sun visor. So you want to keep the paperwork you want to take inside with you. If you have like really high in-car, in-truck temperatures like around 130, 140 degrees, you can fade out your printout. The longer life paper, which is used exclusively in the Testo, has a filing or service life of up to 10 years. That would be under normal, office type conditions. And use of office supply brands of paper, even though they'll fit in the printer, they may have different traction, different longevity. It's really not worth it to go after that. If you're looking to keep a printed record, you want to make sure you have the record, and the office supply brand may not work for you as well as the manufacturer's brand. And then really it gets down to just kind of using your head. Because you're taking part in this seminar, you have to obviously care about using your analyzer correctly, and you are trying to familiarize yourself with it by listening to a broadcast like this. So that's a very good thing. And then you want to understand a little bit about combustion. Well, actually, understand a lot about combustion analysis. What to look for if the readings don't look right. Again, that would be covered in our Combustion 101 session. But if you have an unusually high O2 reading that just doesn't make sense, or a very low carbon dioxide reading that doesn't make sense, it's probably a sampling leak. You've left the water trap open. You've left perhaps the probe, the filter in the probe. You left that loose, where you're getting some oxygen in where it shouldn't be. So just kind of use your head, know what the analyzer is supposed to do, what it's supposed to calculate for you. Don't lose faith in it, and just have some self-confidence. You can understand it. You can break this apart and understand it. You can come back and attend this session again. You can attend our Combustion 101 as much as you like. We'll put the recordings up and available. That way you can get more and more out of this situation, get more and more out of the meter, and feel good and confident in using it. And we talked about several different accessories that are available. The adapter for pressure reading, there's a hose extension available. There's a combustion air temperature probe available in different lengths, and an IR printer. But right now you're getting the IR printer with the meter for that $900 price. There's also a mechanical smoke pump available. And if you wanted to get a mechanical smoke pump at a special price from us, if you didn't purchase one either and you feel you need one, that would be mainly for people doing oil burner work. And I got a draft measurement slide. Can I throw it up afterwards? I'll do that at the very end. Let me just finish up here. I'll keep that question active and I'll do it at the very end. So here's some of the reasons why you'd want to do a combustion test. Some of the results, the outcomes you can have. You can help people save money in terms of burning the fuel, burning it more efficiently, burning it more safely, and also money in terms of having good uptime for the equipment and a long service life. Again, helping increase the warranty, limits your liability if you have a printed result of the kind of testing you've done, increase comfort, increase safety, energy efficiency. There's a lot of positives about doing combustion testing that it should be done really at every logical juncture. Okay, our last slide here, and I will open up the audio in just a second. See if anyone has a verbal question that they didn't care to type in. But if you complete a product review on our site, we will send you a $10 gift certificate. We only want you completing product reviews for products that you've actually used and handled, but you can just pick and choose a product. You don't even necessarily have to purchase it from us, and we will post the review no matter what it says in it. But we want to make sure it's a legitimate review. That we were just trying to build a number of reviews on our site. And okay, we just got a thank you note here. Yeah, per review. We'll do it per review. We'll give you $10 per review, up to a limit of 10 reviews. And I got some thank yous here, and I'm going to stop the recording at this point. Thank you for coming. But I'm still going to be online.